See this question. Set of ordered pair 2, 1, comma, ordered pair 5, 1, comma, ordered pair 8, 1, comma, ordered pair 11, 1, comma, ordered pair 14, 1, comma, ordered pair 17, 1. This is a given relation. We have to identify whether this relation is a function or not. What is the condition a relation to be a function? Tell me. If a relation is defined as a set of ordered pairs, if a relation is defined as set of ordered pairs, then what is the condition that relation to be a function? Do you remember that point? Percy, Dishapriya, Nikhil, Benjamin, Catherine. Unique images. Yes. But here we have not shown this relation. We have not shown this relation in the arrow diagram. In the arrow diagram, we have not shown this relation. This relation is given as set of ordered pairs. Then what is the condition? What is the condition to be satisfied so that this relation is a function? What is the condition? What is that condition? No two distinct ordered pairs. No two distinct ordered pairs should have the same first element. They should not have the same first element. What are the elements here? First elements here 2. This is a 5 and this is 8. This is 11 and this is 14 and this is 17. Yes or no? All the first elements are distinct. Yes or no? All the first elements in these ordered pairs are distinct. So this is a function. This relation is a function because here we are writing the reason also, because no two distinct ordered pairs have the same first element. Okay, my children, you have to remember this point also. Not only through arrow diagram, you have to understand the relation like this also. You have to understand the function. If a relation is given as set of ordered pairs, then you have to observe. You have to observe the first elements of these ordered pairs. If any first element is repeated, then we say that that relation is not a function. But here, if you observe, here first element is 2, here first element is 5, here first element is 8, here first element is 11, here first element is 14, here first element is 17. No element is repeated as first element. Yes or no? Only one time. Every element is given only one time. That is why this relation is said to be a function. Understood this point, my children? Okay. Now come to the second one, ordered pair, set of ordered pair 2, 1, 4, 2, ordered pair 6, 3, ordered pair 8, 4, ordered pair 10, 5, ordered pair 12, 6, comma, ordered pair 14, comma 7. Now, observe this relation. Observe this relation carefully, my dear children. Is this relation a function? If so, tell me the reason. If it is not a relation, in that case also tell me the reason. Is it a function? Tell me.
Yes, sir, it is a function.
Yes, it is a function. Yes, this is a function because no first element is repeated. All the elements in the given ordered pairs are distinct. Here 2, 4, 6, 8, 10, 12 and 14. Okay. We have to find the domain also. Okay. So I will stop this question first. Second question. From the first question, let us write the domain. What is domain? What is the domain? The set of all first elements. The set of all first elements of this ordered pairs. So set 2, 5, 8, 11, 14, 17. This is the domain of this function. Next, what is asked here? Domain and range. What is the range of this function? Set of all second elements. What is the set of second elements? Here 1, 1, 1, 1, 1. So singleton set 1. This is the range of the given function. This is a function and we found here domain of the function and the range of the function also. 3 questions are completed. Okay. Similarly, take the second one. Set of ordered pair 2, 1, ordered pair 4, 2, ordered pair 6, 3, ordered pair 8, 4, ordered pair 10, 5, ordered pair 12, 6, ordered pair 14, 7. Is it a function? Tell me. Is it a function? Is this relation a function? Tell me. Yes. This is also a function. This is also a function because no two distinct ordered pairs, no two distinct ordered pairs have the same first element. Yes or no? So this relation is a function. This relation is a function because no two distinct ordered pairs have the same first element. This is a condition to be satisfied by a relation. Okay, then the relation is said to be a function. Otherwise, it is not said to be a function. Then what is the domain of this function? Domain of the function. What is the domain of the function? Tell me. What is the domain of the function? What is the domain of the function? Yes. Domain means the set of all first elements. the set of all first elements of the ordered pairs. So 2 comma 4 comma 6 comma 8 comma 10 comma 12 comma 14. This is the domain of the function. Then what is the range of the function? What is the range of the function? Yes. Very good, my dear. Percy. Set 1 comma set of all second elements in the ordered pairs. Set of all second elements in the ordered pairs. So 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7. Okay, my dear children, understood this question? Understood this one? Yes. Now come to the question number 2. Come to the question number 2. What is the question number 2 here? Find the domain and the range of the following real functions. Here we have to find the domain and range of the real functions. In the previous question, the function is given as a set of ordered pairs. So it is easy to us to find the domain and range of the given functions. Sorry, third question is there. Third question. In this Roman, third question is there. Third question. What is the third one? Set of all ordered pair 1 comma 3 comma ordered pair 1 comma 5 comma ordered pair 2 comma 5. Now tell me, is this relation a function or not? Is this a relation? Is it a function? Is it a function? Yes, very good, my dear Ria. Very good, my dear Percy. This is not a function. Previously also I told you, the first element should not be repeated in the ordered pairs. What is the first element here? 1. What is the first element in this ordered pair? 1. So 1 is repeated. See here. So this is not a function. This relation is not a function because the first two ordered pairs have the same first element. So because of this reason, we say that this is not a function, this is only a relation. This is only a relation. Okay, my children. Now come to the question number 2. So question number 2. Yes. Now come to the question number 2. Find the domain and range of the following real functions. Given here, f of x is equal to minus modulus of x. In the morning also I told you, domain of modulus function is a real number. Domain of the modulus function is a real number. Okay, so domain of f is equal to real numbers. Now we have to find a range of the real function. If you observe here, before this modulus of x, Range means function values, the values of the function. What is the nature of the values? What is the nature of the values of the function? If you observe here, minus modulus of x means for every time you get a negative number only. All the function values always negative real number. Yes or no? Range of f is equal to minus infinity comma 0. It may be equal to 0 also. If you take here 0, modulus of 0 is 0, minus 0, 0. So this is a range of the given function. Okay, my dear children, understood this point? Understood this one? Yes. Now, I will present a video for the next question. I will present a video. All of you watch the video carefully, my dear children. All of you watch the video carefully. Today we are going to discuss 2.3 exercise, page number 44, question number 2. In this Roman number 2, we have already discussed yesterday. In the previous class, we have discussed the first two. Are you able to? Roman number 2. Now we are going to discuss second question in this Roman number. Are you able to watch the presentation, my dear children?
Yes, sir, but sound is echoing, sir.
Okay. I will turn off my mic and I will present my video. Okay. Number 2. Okay, my dear children. Find the domain and range of the function f of x is equal to square root of 9 minus x square. Okay, my dear children. We have to find the domain and range of this function. What is the function here? F of x. How it is defined? The square root of 9 minus x square. Okay, my children. Now come to the solution part. Given function, first we wrote given function f of x is equal to square root of 9 minus x square. Okay, my children. Now we are going to find domain of this function f. Previously we have discussed in the concepts. Throughout this chapter we are discussing only real functions, means the domain is also real numbers or subset of real numbers, and codomain range also subset of real numbers. So here this value must be a real number, then only we can say that f is defined. So f of x belongs to R. That means this f of x value, whatever the value x is there taken, that entire value must be a real number. When by implies 9 minus x square greater than or equal to 0, this number under the square root must be a positive real number. If it is a negative real number, we cannot get real number. Square root of a negative real number is not a real number. Okay, my dear children, understood this point, why we are taking 9 minus x square. In the morning also I have explained, if a function is in this form, f of x is equal to square root of g of x, then to find the domain, g of x is greater than or equal to 0. Yes or no? Percy, yes, okay. So we use this concept. We use this concept to find the domain of this function. Okay.
So square root of positive non-negative real number. So this number 9 minus x square must be greater than or equal to 0. Understood this step, my dear children? Right. This implies we multiply this inequation. This is an inequation because greater than or equal to symbol is there. So we multiply this inequation on both sides by minus. Then we get here x square minus 9 greater than or equal to changes to less than or equal to because we are multiplying this inequation by minus 1 on both sides. It becomes less than or equal to 0. Understood this step, my dear children? Right. This implies I wrote this x square as it is minus 9 can be written as 3 square. Isn't it or not, my dear children? Right. Less than or equal to 0. Understood this step, my dear children? Right. Now come to this algebraic expression. This is in the form of a square minus b square. You know the algebraic identity. A square minus b square is equal to, what is the identity? A plus b into a minus b. We are using this algebraic identity. So here x means a means x and b means 3. So x plus 3 into x minus 3. I wrote the factors of this quadratic polynomial. Okay, my dear children, this is one factor x plus 3 and another factor is x minus 3. So less than or equal to 0. I wrote this part as it is. Understood this step, my dear children? Right. After that we have to find the value of x. In the rough work I am finding the values of x. I wrote this sentence as it is x plus 3 into x minus 3. Instead of less than or equal to, I wrote here is equal to 0. Instead, just remove this less than or equal to sign. In that place I wrote is equal to 0. To find the values of x I am using here is equal to sign. Remaining sentence as it is. I wrote the remaining mathematical sentence as it is. Understood this step, my children? Right. So x plus 3 into x minus 3 is equal to 0 implies x plus 3 is equal to 0 or x minus 3 is equal to 0. You know how to find the values of x from a quadratic equation. We are following the same steps here. Okay, my dear children? Right. This implies x is equal to minus 3. Plus 3 becomes here minus 3. Similarly, from this equation, we get x is equal to 3. So these are the values of x. X is equal to minus 3, 3. Understood these values of x, my dear children? Right.
Understood these steps, my dear children? How to find domain of these functions? Let us move to the next step. After that, I will ask you question. Okay.
Now come to this step. Here the values of x are minus 3, 3, and here we got less than or equal to 0. There is a property here. In the inequalities, there is a property. What is this property? X minus a into x minus b less than or equal to 0 implies x belongs to closed interval a comma b. Here a means minus 3 and b means plus 3. Okay, my dear children, that is why I wrote this step. Understood this step, my dear children? Right. Therefore, domain of f is equal to closed interval minus 3, 3. Whatever the values x takes, that values are said to be domain of the function. Understood this part, my dear children? Right. We have completed the first part of the question, that is finding the domain of the function. Okay, my dear children. Now come to the second part of the question. What is the second?
Understood, my dear children, how to find the domain of a given function? My dear Percy, Disha, Priya, Nikhil, Ria.
Yes, sir.
Vinisha,
Yes, sir.
Catherine, Benjamin, Rexlin, Samuel, Richan, Jose. Yes. Okay. Can we go to the next part? Can we go to the next part?
Yes, sir.
Finding the range. Finding the range. Okay. Please watch the video carefully, my children.
Second part
Second
of the
part of the
question,
question,
we have to
we have to
find
find
the
the
range of
range
the
of the
function
function
f.
f.
Okay, my
Okay,
children.
my children.
So
So
range of
range of
f.
f.
We have
We have
discussed
discussed
the
the
steps
steps
to be
to be
followed to
followed to
find the
find the
range
range
of a
of a
function.
function.
We
We
follow the
follow the
same
same
steps
steps
here.
here.
Please
Please
bring
bring
back to
back to
your
your
mind
mind
those
those
steps.
steps.
Okay, my
Okay, my
children.
children.
In the
In the
previous
previous
class,
class,
yesterday in the yesterday video, we
we
have
have
discussed.
discussed.
Remember
Remember
the
the
steps.
steps.
What is the
What is the
step
step
one? We
one?
have
We
to
have to
assume
assume
that
that
y is
y
equal
is
to
equal
f
to
of
f of
x. We
x.
have
We
to
have to
write
write
this
this
equation.
equation.
They
They
don't
don't
give. We
give.
have
We
to
have to
follow
follow
these
these
steps.
steps.
Okay, my
Okay, my
children, y
children,
is
y is
equal to
equal
f
to
of
f of
x.
x.
This
This
implies
implies
f of
f
x
of
is
x is
equal to
equal to
y.
y.
F of
f
x
of
is
x is
equal to
equal to
y.
y.
This
This
implies
implies
what is
what
f
is
of
f
x
of x
here?
here?
Square root
Square
of
root of
9
9
minus x
minus x
square is
square is
equal to
equal to
y.
y.
In
In
LHS,
LHS,
instead of
instead of
f of
f of
x, I
x, I
wrote
wrote
square root
square
of
root of
9
9
minus x
minus x
square
square.
is equal to
Sir.
I
I
wrote
wrote
RHS
RHS
part
part
as
as
is.
is.
Understood?
Understood?
Yes.
Sir, it's echoing, sir.
Okay. I forgot to turn off my mic.
This step is done. Right. So, we have discussed. Remember the steps. What is the step one? We have to assume that y is equal to f of x. We have to write this equation. They don't give. We have to follow these steps. Okay, my children, y is equal to f of x. This implies f of x is equal to y. F of x is equal to y. This implies what is f of x here? Square root of 9 minus x square is equal to y. In LHS, instead of f of x, I wrote square root of 9 minus x square is equal to, I wrote RHS part as it is. Understood this step, my children? Right. After that, second step. What is the second step? We have to find the value of x in terms of y. From this equation, we have to find the value of x in terms of y. So for that, I took squaring on both sides. By taking the square on both sides, we get 9 minus x square is equal to y square. Understood this step, my children? Right. This implies x square is equal to 9 minus y square. X square is equal to 9 minus y square. Understood this step, my children? Right. This implies x is equal to plus or minus square root of 9 minus y square. Okay, my children? Understood this step? Right. Now come to the step 3. We have completed step 2. What is the step 2? We have found the value of x in terms of y. We have completed second step. Understood this step, my children? Right. Now come to the step 3. What is the step 3? We have to solve this equation. Solving the above equation. We have to solve the equation. Means we have to find the values of y. Okay, my children. So here x is equal plus or minus square root of 9 minus y square is a real number. When it is a real number, same as in the case of domain, we follow the same steps. From here onwards, to find the values of y, we follow the same steps as we followed to find the domain of function. So 9 minus y square should be greater than or equal to 0. Only in that case, this entire number is a real number. Under this square root, the number under the square root must be non-negative real number. So we wrote like this: 9 minus y square greater than or equal to 0 means it is a non-negative real number. Understood this step, my children? Right. This implies here I multiplied this inequation on both sides by minus 1. Here I multiplied this inequation on both sides by minus 1. Then we get here y square minus 9 is less than or equal to 0. Previously I told you, if we multiply the inequation by -1 on both sides, greater than or equal to changes to less than or equal to, less than or equal to changes to greater than or equal to. So here greater than or equal to changes into less than or equal to. Understood this step, my dear children? Right. This implies y square minus, I wrote here 9 as 3 square. Can we write it or not? Yes. So I wrote here 3 square less than or equal to 0. Understood this step, my dear children? Right. This implies if it is in the form of a algebraic identity a square minus b square, where a is equal to y and b is equal to 3. So I wrote the factors of this quadratic polynomial. So y plus 3 into y minus 3 is less than or equal to 0, because a square minus b square is equal to a plus b into a minus b. We are using this algebraic identity in this step. Understood this step, my dear children? Right. This implies y belongs to closed interval -3, 3. Because in the rough work we have got the values of y -3, 3. As in the case of finding the domain, we've got x is equal to -3, 3. Here also we got the values of y is -3, 3. So here y belongs to closed interval -3, 3. But the range of f is equal to closed interval 0, 3, because y is considered as square root of 9 minus x square. It is a positive square root. Y does not take negative values. That is why here we are not taking negative values on the number line -3 to 3. But in this interval we exclude negative real numbers. So 0 to 3 we take only non-negative real numbers. Understood this step, my dear children? Right. So please note this point. While finding the range or domain of a function, please be careful on squaring the function. Sometimes it may give some extra values. So we have to be very cautious, very careful. See here, the y values we have got -3 to 3, but actually function values are from 0 to 3 only. Okay, my dear children, understood this difference? Right. Now come to the question.
Understood this question, my dear children? How to find domain and range of a given function? Yes. Okay. Yes. Disha Priya, Samuel, Nikhil, Vinisha, Catherine, Benjamin, Rexlin. Yes. And watch the video again. Okay. If any confusion is there, again watch the video. Okay. Now, next question number 3. Please watch the video carefully, my dear children.
Number 3. In this exercise, question number 3 and the next question, that is question number 4. Both are of the same type of questions. Okay, my dear children. So, I am explaining here question number 3. You try question number 4. Okay, my dear children. Will you make an effort to find the question number 4, to solve the question number 4? Okay, my dear children. Right. Are you listening to me? Right. So a function f is defined by f of x is equal to 2x minus 5. Here f is defined like this, 2x minus 5. Write down the values of first part f of 0, second part f of 7, third part f of -3. 3 parts are there. This is the first part, this is the second part, and this is the third part in this question. So let us find one by one. Okay, my dear children, understood this question, my dear children? Just to substitution. If you have substitution skills, it is very easiest question. Okay, my dear children. So come to the question. What is the function here? F of x. So f of x is equal to 2x minus 5. I wrote the given function here. Now come to the first part. F of 0. In the place of x, what is there here? 0. So in RHS also, in the place of x, write 0. Substitute x is equal to 0 in RHS also. So 2 into 0 minus 5. What will you get? The value of the first term 0. 2 zeros are 0 minus 5. Now simplify these two terms. What will you get here? Minus 5. Understood these steps, my dear children? Right. Therefore, f of 0 is equal to minus 5. This is the value of the function f at x is equal to 0. We can say that f of 0 is equal to 5, or the value of the function f at x is equal to 0 is minus 5. Understood, my dear children? Right. Now come to the second part, that is f of 7. In the same function, we are substituting x is equal to 7. So 2 into 7 minus 5. In this function, we are substituting x by 7. We are replacing x by 7. So f of 7 is equal to 2 of 7 minus 5. Understood this step, my dear children? Right. That is equal to. So here we are going to find f of 7. We are going to find the value of f of 7. So in this function, we substitute x is equal to 7. We replace x by 7. So 2 into 7 minus 5. Okay, my dear children, understood this step? Right. That is equal to, what is the value of here? First term, 2 sevens are 14. So 14 minus 5. Understood this step, my dear children? Right. 14 minus 5. What do you get here? 9. Understood, my dear children? Therefore, f of 7 is equal to 9. So the value of f of 7 is 9. We can say that the value of the function f of x at x is equal to 7 is 9. Okay, my dear children, we can say like that also. Now come to the third part. Third part, f of minus 3. We have to find the value of f of minus 3. We follow the same procedure as we followed in the case of first and second part. We substitute x is equal to minus 3 in this function. We replace x by minus 3. So 2 into minus 3 minus 5. Just we substituted x is equal to minus 3. Understood this step, my dear children? Right. That is equal to 2 into minus 3. What you will get here? Minus 6 minus 5. Understood this step, my dear children? Right. Minus 6 minus 5. What will you get by simplifying these two numbers? Minus 11. Understood this step, my dear children? Right. Therefore, f of minus 3 is equal to minus 11. This is called the value of f of minus 3. Or sometimes we can say that the value of the function f of x at x is equal to minus 3 is minus 11. Okay, my dear children? Right.
Understood these questions, my dear children?
Yes, sir.
Can you prepare the classwork notes by yourself by watching this video?
Yes, sir.
I will post this video in the classroom. I will post this video in the classroom. Can you prepare the classwork notes by watching this video? And can you do the remaining sums? Whatever the sums were not explained in the video. Can you do the remaining sums in the exercise? Yes, very good. Very good, my dear children. If you have any doubt or if you confuse anywhere, please feel free to ask your doubts and get your doubts clarified. Okay, my dear children? Yes. Now the time is 4:16. Now you can leave the meeting, my dear children. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. Use sanitizer for cleaning your hands frequently. maintain social distance of 2 meters from others, and do your work sincerely and seriously. Okay, my dear children. What, my dear Nikhil and Benjamin? Still you are online? Why are you staying back online? Nikhil, my dear Nikhil and Benjamin, are you there online? Benjamin and Nikhil, why are you staying back? Still you are in the online? What about Nikhil? Nikhil, my dear Nikhil, still you are online? Nikhil, my dear Nikhil, I think you are not there online. Just you turned on your laptop or PC and you went somewhere. You are not responding to my question. I am removing from the meeting. I am removing you from the meeting.